Hi everyone, this is part 3 of our TVM and finance review. We've got 3 more questions. Let's dive in. We have a savings account with this interest rate. We have $1,500 already. We want to save up $8,000 in 3 years. So how much money do we need to deposit at the end of each month? Let's highlight the information, the numbers, and the things that we are going to use for our calculation. So we've got our rate here. We're compounding it monthly. That's going to be important. So that's 12 times in a year. We've got our present value, our future value, how many years we're going to be saving up. And what we want to solve for is what our payments are going to be at the end of each month. If you remember, the end of the month means that we need a 0 when we do our calculation. Hopping over to our spreadsheet here, I've already filled in the first numbers. Our present value is negative. Again, we are taking that money and depositing it. So we're taking it out of our pocket, depositing it into our account. At the end, we want a future value that is positive because at the end, we are taking that money back out. We have our interest rate and the number of years. Now, like the question said, our effective interest rate, that means we need to take this rate and divide it by the number of times we are compounding every year. It was monthly, so we'd have to divide this by 12. So equals, click on this, and then /12. Same thing for the number of years, except for instead of dividing by 12, we are going to be multiplying by 12. So we take our number of years, multiplied by 12, equal sign at the front, hit enter. For the payment amount, equals PMT, open brackets. Hopefully you see this here. A reminder, if you don't, you should see this little question mark. Click on that and this will pop up. And now we just need to click on our numbers above, fill it in, and we should be good to go. So our rate first, this is going to be our effective rate, number of periods, present value, which needs to be negative, future value, which is going to be positive. Now the question said that we're doing it at the end of each month, so that means we need a 0 here. Now our payment is negative in this case, and that makes sense because that money is coming out of our pocket into our savings accounts. So it's money coming out of our pockets, which means it should be negative. If you get a positive number, you know you did something wrong here. Let's move on to number 4. We want $1,100 for a new computer. We can deposit $10 at the start of each week into a savings account and buy the computer in 2 years. What does the annual interest rate of the account need to be if it is compounded weekly? Start by highlighting and writing down all of the key pieces of information. We know the future value. We know how much we're putting in every week at the start of the week. So we know our payment, we know that it's going to be a 1 because it's at the start. We're doing this every week, that's 52 times a year for 2 years, and we want to know the rate. So this is what we're trying to solve for. I've put this all into a spreadsheet. If you notice, we're not actually told any information about the present value. So I guess we assume that there's no present value. That's the only assumption we can make. Our future value will be positive because we're taking it out. Our number of years is 2, but our number of periods is going to be that number multiplied by 52 because we're doing it every week and there are 52 weeks in a year. Our payment is $10 every week, but this has to be negative because it's coming out of our pocket going into our savings account. To calculate our rate, we use the rate function, so equals RATE, open brackets. We hit the number of periods, payment per period, present value, future value, and in this case, we want to put in if it's the end or the beginning. Like it said, it's at the start, so this needs to be a 1. Now there's one more option here that you'll see, rate guess. So you can actually put in a guess for what you think the rate is going to be. This is helpful on Microsoft Excel. You don't need to do this for Sheets. If you have this on Excel, my suggestion is to put in a rate of 0.1%. If you're doing it on Sheets, this is the default. It'll work almost all the time anyways, but if you're in Excel, you have to put in this guess because they don't use this as the guess. They use 10%, which is really silly and often causes problems. If you're finding that this is spitting out errors, put in your own guess and make it a really small percentage, like 0.1 or 0.01%. And there we go, we get our rate, but our rate seems kind of strange. It's only 0.1%, and that's pretty small. But we have to realize that when we do this rate calculation, the rate that we're solving for is actually the effective rate, not the annual rate. So this is what the effective rate is every week. If we want to get the annual rate, we have to do this number times 52. The reason we're multiplying by 52 is if we were going the opposite direction, we divide by 52. So if we start with our annual rate, we want our effective rate, we divide by 52. Going the other way, we have to multiply by 52. Now we were asked in the question for 2 decimal places. So you could just round this by looking at it with 2 decimal places, but you can actually do it in Excel. If you go up to the top here, you can move your decimal places around. So you can either increase the number of decimal places, which is not what we want. We actually want to decrease the number of decimal places until we get 2, and it will automatically round it for you, and we can see our answer right away. The last question here is a couple deciding they want to start saving. They have $3,900 making a deposit into the account at the end of every semi-monthly period. The account offers 3.98 annual interest rate, compounded semi-monthly. How many years will it take for them to save up $40,000. Let's highlight the important information. So we're told about the present value. They have $3,900. They're paying $140 every semi-monthly period, which means 2 times per month. There's 12 months in a year, which means it's going to be 24 times per year. We have our interest rate, compounded semi-monthly, so 24 times per year. And we want to know how many years, so that's what we're solving for, the number of years, to get this future value of $40,000. I've already added in all of the information. Our present value, which is negative because we're depositing it. We have our rate, and then our effective rate, which is dividing by 24 because we're doing this 24 times every year, twice a month. Our future value is positive. Our payments are going to be negative because that's coming out of our pocket into our savings account. And now we can calculate the number of periods. Again, we want to know the number of years. That's related to the number of periods. So equals NPER. We click on our effective rate, our payment amount, our present value, our future value, and we want to know if it's at the end or the beginning. In this case, we're told that it is at the end, so we need a 0 here. And we see 206. Now you might think 206 years, that's a long time to be saving up for your child's education, but we have to remember that this isn't the number of years, this is the number of periods. So this is how many times we're making that $140 deposit. These periods are happening 24 of them every single year. To get the number of years, we need to do the opposite of what we would do before in our previous calculations. So if there's 24 in every year, we need to take this number and divide by 24. Just like last time, we want 2 decimal places. So either you can round this just by looking at it, but I would suggest using the function here to move it down to 2 decimal places and you can get your answer, 8.62 years. That's a lot more reasonable to save up for your child's education. Please make sure you check out this spreadsheet. I'll put a link to this in the description and in our Teams. Hopefully this was helpful. Please post any questions in our group chats, and I will see you in the next video.